Okay. So the topic for today is force. What comes to your mind when I first say force?
Could it be like the thing when it comes to mind for me is push and pull?
Okay, push and pull probably because you've done it before. What else would come to your mind?
Energy.
An engine.
Energy, kind of an engine. Okay. What
Something which
else?
is used to move stuff.
Okay. So okay, so now we join the words that you all have given me. Okay, so the energy that is there within yourself, you all are using to move something, correct? So it could be in the form of a push or a pull. It could be either you're pushing something or you're pulling something. Means it could come towards yourself or it could go away from yourself also. Okay, so basically the energy that is in yourself that you're using to move something would be called as a force. Okay. Is it necessary that all the time the force that you apply is going to produce some kind of motion? Will all the time the force uh, cause motion?
Only if it's strong enough.
Only if it's strong enough. So if supposing I am using my hands to move the ball, will that produce motion?
No.
No,
No, it won't.
no, correct. So force, yes, it is going to be a push or a pull, but we also have to define it in terms of uh, whether it is able to move something or no. Okay. Otherwise, that force is of no use. It is not going to really produce any kind of work done. Okay, so that kind of concept we do more in detail when we are doing work done. But I'm just brushing through it right now. Okay, so we'll go to our first slide. Okay, so there are a certain definitions that I hope you all know, and if you don't know, it is going to be for the first time for you all. When I say state of rest, what does it mean when I say state of rest? When I mean state of rest, I mean that something is not changing its position with respect to time or with respect to an observer. Okay, why do I put these two concepts with respect to time and with respect to an observer? Because it is very, very important. You will come to know when I go to the third concept of it. When I say that rest and motion are relative terms. Okay. So state of rest is when you're not changing the position with respect to time and with respect to an observer. What is state of motion? When the body is changing its motion, when the body is in motion and it's changing its position with respect to time and with respect to an observer. Now, if I am seeing that this boy is sleeping or this giraffe is sitting, what will I say? What will I say? It is in state of
Rest.
Right.
rest. Okay,
Rest.
rest. Yes. Now, if supposing I saw it at 10 o'clock on Tuesday, okay, and I saw it, okay, and I turned my back. I turned my back. Okay. Now it's Adya's turn. Adya is seeing the giraffe and Adya is seeing the boy. But what did she see? He saw that the giraffe started to move and started to run, and the boy now blinked his eyes. Now were both of them in state of rest?
No.
No.
No,
No.
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 So the state of rest and the state of motion is going to change because I saw something else and Adya saw something else. Correct? So that is why we say an observer with respect to the observer. So the term state of rest and state of motion, they are relative terms. They are relative. Why? Because they can be same for a set of period or for a set of objects. So that is why you can say that rest and motion are relative terms. Okay. Now I'll tell you very easy example by which this will become very clear. Okay. Now you are in the train. You are in the train. Okay. The train comes and stops at the platform. Okay. Now you are seeing the man who is selling tea at his tea stall. Okay. So for you, that man at the tea stall is standing there only, itself only. So you will say that he in state of state of
Rest.
rest. Correct. Now your train starts to move. Now your train will start to move. So what will happen? You will say that
State
that
of
man,
motion.
yes, that man has come in state of motion. Now the same thing can be in opposite way. Okay, that man at the tea stall, when the train was at stop, he saw you and he said that you were in state of rest. The minute the train started moving, he will say that now you are in state of motion. Correct? Right? But,
Yes.
but, but.
Yeah.
Okay. Now I'll put another but out here. Now that was one set of terms, one set of terms. Okay. So he saw you in state of rest and in state of motion. Had you changed your position? Had you changed your position in the train?
No.
No, correct. Now the man sitting next to you, the man sitting next to you, for him, you were in state of rest when the train was in rest also, and when the train is in motion also. Is it getting confusing?
A little bit.
A little bit.
Okay. See, now whenever I'm talking about rest and motion, no, you always take it with respect to the person who is observing you and who's giving the statement that that thing is in rest or that thing is in motion. So you are the object. You are the object. And there are two observers. One observer is on the train and one observer is off the train. Okay. The observer who is off the train, he will see you in two states. When the train had stopped at the platform, he will see you in state of rest. The minute the train will start moving, he will see you in state of motion. Okay. Now the person who is sitting next to you, even when the train was stationary or even when the train was moving, he is going to see you in state of rest only because you haven't moved from your place. So this is why we say that rest and motion are relative terms. Rest and rest and motion will be according to
Okay.
the observer. Okay, this concept is very important. State of rest, state of motion, and according to the observer. That is why you always say that rest and motion are relative terms. Clear, everyone?
Yes.
Yes? Jia, Ria, Adya,
Got it.
uh,
Yes,
and
ma'am.
who else is there? Vedika. Clear? Vedika, clear? Adya, clear?
Yes, ma'am.
Okay. So why are we taking these terms? Because force. Whenever you deal with the concept of force, you always then go further to the topic of motion. Okay. So whenever you're talking about force and motion, you'll talk about what is force and types of forces and all those things. Okay. When you go to the term of motion, when you go to the term of motion, the motion will talk about the laws of motion. Who gave the laws of motion? Any idea? Who gave the laws of motion?
Newton.
Yes, he gave
Newton.
Newton's 3 laws of motion. Are there no? First law, second law, third law.
Yeah.
So when you talk about those motion laws, you come with these terms. Okay, that is state of rest, state of motion. Rest and motion are always relative. That is why this concept is very, very important for us to get it cleared out. State of rest is there, state of motion is very clear. See, to understand rest and motion is very clear. Rest is when something is not moving at all, motion is when something is moving. But they both are always relative, means they are according to a observer. They are for one set of an observer, they could be at rest and rest. For the other set of observer, it could be at motion. Okay. Can y'all tell me one example? Can you think some example like this and tell me? Come on. Anyone?
When we sleep, we are in a state of rest, and when we wake up, it is state of motion.
Okay. Can you tell me in relativity term?
Like let's say you're in a car and you can see a plane above you.
Okay.
You could say you're at rest, and the plane is moving.
Okay.
And let's say we're on the plane, and the plane you would think you're at rest, and the car is moving.
Correct. Okay. Right? Understood, everyone? Anyone else has any such examples? Or you want me to move on?
I understand the
now?
concept, but I can't think of an example.
Okay, fine. Great. So now we'll go to the term of force. Okay. What is force? We'll go to our slide. Next slide. Uh, force is basically that will try or that will change. Okay, first it is going to try and then it will change. If it is successful, well and good. So it is going to change. It is going to change or it is going to try to change the state of rest or state of motion of an object. Okay, so if something is in rest, you are bringing it in motion. If something is in motion, you are bringing it at rest. That is what you, as a whole, you will define as a force. Okay. In general terms, we always say force is either push or force is either pull. Normally, okay. We also add a few terms to it, like we add stretch and we add squeeze. You add stretching or squeezing. Okay. So such things, when it happens, you call it as a force. So if something is in rest, you're bringing it in motion. If something is in motion, you're bringing it at rest. Clear? Very clear? What is force?
Yes, ma'am.
Okay. I want you all to give me examples of force. Anything. So many things.
You could pull open a door.
You could pull open a door. Very good.
Cutting vegetables.
Cutting vegetables. Yes.
You could squeeze you could squeeze, how do I, you could squeeze out the water from
Clothes. From
clothes, yeah.
wet clothes. Okay. Okay. Next.
Playing an instrument.
Playing an instrument, yes. Yeah, there also you're pulling, you're pushing. Correct?
Like when you play a guitar.
Yes, when you play guitar. Correct. Who is left? Adya is left.
No, ma'am, I said the instrument.
Okay, you said the instrument. Okay. Everyone finished? Everyone gave answers? Or anyone left? Okay. I think everyone gave the answers. Okay. So force is either a push or a pull. Okay. You can also add terms like stretch and squeeze. They are type of push pull only. Okay. Okay. And what is force? Force is when you are trying to change the state of rest or state of motion of an object. If something is in rest, you bring it in. You bring it in motion. If something is in motion, you bring it at rest. Okay. Next. Next slide. What are the effects of force? Hmm? Force, what can it do? What things can it do? Okay. So when you are pressing, okay, so when you're pushing, right? So what you're pushing and what you're doing, you're changing the size and the shape of the object. So if I have got a sponge in my hand, I am squeezing it, means I'm pushing it. It could be squeeze or it could be push. I'm changing the shape and the size of the object. Okay. The other thing, force, what can it do also? It can also change the motion of the object. That is what it is. If the force is in if the object is in stationary, means if the object is at rest, it can cause the object to move, or if the object was already moving, it can cause the object to either slow down or either stop. Okay, you can either slow down the object or you can stop the object. Okay. Third thing, the force can also change the direction and the speed. Speed is what we just spoke about in the above case also. You can either speed up or you can either slow down. So basically, what are the effects of force? What things does it do? Come on, tell me. What things will the force do?
It can change the size, the shape and size of an
Okay,
object.
shape and size. First thing is shape and size. Okay, next.
Forces can change the motion.
So it is changing the motion, means either it is setting the rest in motion or it is keeping the motion, bringing the motion to rest. Okay, that is second. What is the third one?
Direction.
Direction and speed.
Direction. The third
Oh,
one will
sorry,
be
sorry, yeah.
direction, and the fourth one
That's
will
all
be
right.
the fourth one will be the speed. So four things. Okay, shape and size. Okay, shape and size is the first thing. Shape and size, you can very simply you can do an example of a clay, of a play-doh, your clay. Okay, you take the clay and you mold it, so you're changing the shape and size using your muscular force. Okay. Next one, second one, if it is in motion, you're bringing it at rest, and if it is in rest, you're bringing it in motion. Very simple example is there. Okay, if supposing something is if supposing your scooter, okay, your scooter has just started, you're starting the scooter. Okay, so you from rest you're bringing it in motion. Okay. The second thing, if your scooter was moving, you are stopping it, so you brought from motion into rest. Okay. Third thing, you are going straight on the bike, you take a left turn. The minute you take a left turn, you're changing the direction. Okay. And the fourth thing is the speed. You have a bike, you accelerate the bike. If you accelerate the bike, you're increasing the speed. And if you put brakes, you are decreasing the speed. So that is what you say, that the force will either change the direction and the speed of the object. Okay?
Ma'am, I have a
Yes,
question.
yes, tell me.
So if like your bike example, so like you're going on a bike,
Hmm.
so you take a right turn, so you're changing the direction of your motion, and
Correct,
and with the speed, when you if you choose to slow down, you're bringing the bike to rest. Is that
correct,
right?
correct.
Okay.
Yes, yes,
Okay.
correct. Okay. So these are the effects of the force. Force is either push, pull, stretch, squeeze, whatever we spoke about. And what effect it produces are all these kind of effects. Okay, clear? Clear, everyone?
Yes.
Okay, we'll go to our next
Yes,
slide.
ma'am.
Okay, we'll go to our next slide. Okay, so force, the first time the force was introduced, and it was introduced by Isaac Newton. He discovered the first type of force. Which was the first type of force that he discovered? What is the type of force he discovered?
Gravity.
Gravity?
Yes, yes, say loudly. It's okay. You can be right, you can be wrong. Sometimes it could be a different perspective also. So you have to say loudly, okay? Okay, gravity. So Isaac Newton, he discovered gravity. And then when he studied it, he came to know that it is a type of a force that is because of the gravity of the earth. Gravity of the earth that is causing a force to pull the things down. Okay, so that is what he discovered. Okay, so in general, whenever we want to use a unit for force, the unit for force that we use is Newton. Okay, we use the unit Newton, and the symbol used is capital N. Okay, for example, if I am using the units for length, what will you use the unit for length? What is the unit for length we use?
Meters?
Meters, right? Meters, kilometers, and so on. Out of those, the SI units that we use is meter for length, right? The same way, the SI unit for force is Newton. Okay, and there is another unit also which is called as dyne. But right now, I don't want to confuse you all with it. Okay, right now, just remember the SI unit for force is Newton, and you write it with a capital N. Okay, so whenever,
And
yes,
so I learned about Newton. So it's like if you're pushing from one side and if you're pushing from the other side, and then there's 6 newtons on one and there's 5 newtons on the other.
correct.
Like which one is bigger? Like those kind of questions.
Yeah, so that will come in the topic of balanced and unbalanced force. So what you spoke was unbalanced force, correct? Because one side was 5 Newton and one side was
Six
1 Newton.
newtons.
One one acha, 6 Newtons. One was 5 Newton and one was 6 Newton. So now the force will be more towards the 6 Newton side. So what will
Yeah,
happen? The 6 Newton will be able, if you're pushing, then that object will push towards
towards
the
that side.
person.
Yeah.
Yes, opposite, huh? Opposite, because you're pushing. Because you're pushing,
Yeah, yeah,
so it will be opposite of the person who is pushing with 6 Newton. If he was
yeah.
pulling, then it will pull towards himself with that 6 Newton force.
Okay, got it.
Okay, okay. So now tell me one thing. There's a concept of momentum. Okay, what is that? Okay, so that is called as, when something is already in motion. For example, okay, when you start to pedal the first time your cycle, what happens? Do you feel more force?
Yes.
Yes, you feel a
Yes.
lot of force, because all of y'all means your bike, yourself, everything is in state of rest. Now from state of rest, you're moving to state of motion. So you have to create the momentum. You have to go from zero to something. So there you will be applying more force. Okay, now the minute you have already set in motion, okay, now you already cycling. Now what happens with the cycling? Now you want to increase the speed. Now you're already in motion. Do you have to apply a lot of energy to increase the speed, or little bit energy to increase the speed?
Just a little bit.
Just a little bit, right?
Definitely.
Because you're already in the momentum, you're already in that kind of motion. Okay, understood the concept of momentum? So whenever there's a change in the momentum, you call it to be a force. Initially, what was the momentum when your bike was at zero? Okay, you had to start it. So there you changed the momentum. From rest, you went to motion, And so there you change the momentum and you applied force. Okay. Similarly, if your bike was in motion and you increased the speed, the momentum you changed, whatever it was, X, Y, Z. For example, it was a speed of 10, you increased it to a speed of 15. The change in momentum happened because you applied force. Okay. Or if supposing it is at a speed of 10, you are applying brakes. The minute you apply brakes, the momentum also comes to a rest. It becomes zero. So again, change in momentum. So that is what is called as your force. Okay. So whenever we want to define force, you always take two concepts into account. You take mass and you take the acceleration. By acceleration, in general, they mean the change in the speed. Okay. So it could be positive acceleration. So that would be acceleration positively. When it is negative, it will be called as retardation. Okay. So force is equal to mass into acceleration. Force is equal to mass into acceleration. This law will be clear when we do Newton's laws of motion. Okay. I am giving this concept because all of y'all are pretty big to understand it. Is there any doubt why we are doing this? How the force is equal to mass into acceleration, or why it is, or any questions related to it?
Ma'am, if we need
Yes.
to calculate like the
Vedika,
force.
can you speak a little louder? Your voice is very low.
Okay. How do we get the acceleration? Like,
How do
how
you
do we
get the
measure it?
acceleration?
Yeah.
Okay, so you will get the acceleration by knowing the initial and the final acceleration. Initial and final speed. So acceleration will be final speed minus initial speed. So if your cycle was at rest, your initial speed will be 0, and when your cycle sets in motion, your final speed will be, for example, say 10. So your acceleration will be the change in the change in your speed, that is 10 minus 0 divided by the time. In how much time did you accelerate it also? So acceleration is always equal to final velocity minus initial velocity divided by the time. That is how you get the concept of acceleration. Okay. This concept is very, very clear when we do the Newton's law. Newton's law speaks about acceleration in one of its laws.
Okay.
Okay. Clear? So
Yeah.
Clear.
yes. So force will depend on two terms. One is mass and one is acceleration. Okay. And the SI unit for force is Newton, that is capital N. Okay. If you see in the formula, if I want to break up the formula, okay. Do you know something about units? In units, you have got something, those are called as basic units, and something that is called as derived units. Do you know this concept of derived units and basic units?
No.
Okay. So, what is the unit of length?
Meters.
Hmm?
Meters.
Meters. Okay. What is the unit of area?
Meters square.
Why did you say meter square?
Because it's the unit.
How? Why? How and why? It's very logical.
Because um, it, it's like
What
a
is the formula
square.
of area? What is the formula of area?
For a square, it's side square.
It's
For a
length into length. Length into length.
yeah.
Any area you take, it is going to be length, one length into the second length. If you take a rectangle also, it is going to be length into breadth, and both of them have the units, meters.
Yeah.
Correct? Correct?
Yes.
Yes.
So it will be meters into meters. It will be meter into meter. That will be meter square. Okay. So now when the area was dependent on two basic units, so now area will become a derived unit. You derived it from the basic units. Understood or no? Still confused?
I got it.
Okay.
Got it.
Let's take another example. Area, volume. What else do you all know? Which other quantities you all know? Tell me. So I'll give that example. Any other formulas you know? You all know the formula of density?
Yes, but I don't
Yes,
exactly.
ma'am.
Yeah, I do know it.
Ma'am,
Density.
uh,
What is the form?
density is equal to mass divided by volume.
Oh, very good. Density is equal to mass divided by volume. So density is again dependent on two other factors, on two other units. It is dependent on mass also, it is dependent on volume also. So the density unit will be uh, the unit of mass, that will be kg or grams, whatever it be, divided by the volume. So volume unit is either meter cube, centimeter cube, or so on. So density you will say is kg per meter cube or grams per centimeter cube. So then your density becomes a derived unit. Same way, force will become a derived unit because it depends on two factors. It depends on mass also and it depends on acceleration also.
Ma'am,
Okay,
another example is speed.
very good. Speed, very nice example. Speed is equal to change in distance upon time. So speed is equal to distance ka unit divided by the time unit. So it will be meter per second. Understood? So that same way, the unit for force will be dependent on two units, that is mass and acceleration. So the unit for mass will be either kg or grams, whatever you take as per your unit values, and the unit for acceleration will be meter per second square or centimeter per second square and so on. Okay, but when you combine them together, you can give it one name, you can call it Newton. So you can give the unit name of Newton also, you can give the name of the unit kg per kg meter per second square also. This is how you call these units, are called as derived units. Okay, so for y'all a homework is there. Okay, y'all are going to go and you're going to do a research on basic units. Those are called as fundamental units. Fundamental units and derived units, and give me three examples of not the ones that we discussed, huh? Other than we discussed. You're going to give me three examples of fundamental units. Fundamental units so will be the same only because they are going to remain the same. But three examples of derived units. Okay, clear?
Clear.
Clear?
Clear.
Okay. So for force, the unit that we use is Newton. Okay, now we will go to our first experiment. Okay, next slide. So we'll go to our first experiment. In the first experiment, you're just going to look at the observation sheet. If you all have removed the printout, you can write it there and there itself or only. If you do not have a printout, you can write it in a pen or and book somewhere. Okay, so we'll go to the observation table. Okay, so here there are four things that is happening. Okay, out of the four things, each one of you all are four of you all only. Okay, so I'll tell one's name. You're going to tell me whether it is push or a pull, whether there has been a, what was the effect that it created. Did it change the state of motion or did it change its shape, size or direction? Okay, any one of them. Okay, so you are going to tell me and you're going to write it down there. Okay, understood?
Ma'am, can you give me a second to get my book?
Yes, yes, no harm.
Okay, thanks.
Please get a book and a pen or a pencil, whatever is fine. Okay. Others are ready? Ria, Vedika,
Yes, ma'am.
Adya, ready? Ready? Okay. Jia, you're back? From next time, you all can sit with a pen and a book always in the class if you want to just note down things. Okay.
Okay, ma'am, I got my book.
Okay. Okay. So first one we'll go with Vedika. You'll answer the first one.
Yes, ma'am.
So what is the man doing or the lady doing or whatever? What is the hand doing?
Kneading.
The
Kneading the
hand is
dough.
okay. So is it a push or a pull?
It's a push.
It is a push. The first one is a push. What is it doing? Is it changing the state of motion or is it changing its shape?
It's changing the shape.
It is changing the shape. Okay. It is changing the shape. Good one. Okay.
Oh, ma'am,
Yes, Ria.
will it also be changing in size as well?
Yeah. Shape, size, all that will come in that only column. So you'll
Okay.
change the shape, you'll change the size of it. It'll all come in that same column. Okay, so you can write it down. It is a push, and you can tick it in change in shape if you have the thing, or you can write change in shape out there. Change in shape, comma size. Okay. Next one, Ria, you'll go.
Okay, so the man, I don't get the image. What does it say in the image? There's a bit of writing there.
Okay, he's just cycling.
So he's pushing.
He's pushing. Okay, he's pushing. And what is he doing? What is the effect that he's creating because of his force?
Uh, Speed.
Speed, right? So
Change in
what will be? So it could be speed, it could be from rest to motion, or it could be from motion to rest also, anything. So we'll
the
put it in
change in
change in,
speed and motion.
yes. So you can write it down, change in motion, comma, speed. Okay. Next one, Adya, you'll go.
Ma'am, there was a change in shape for the first one, right?
Yeah, change in shape for
Okay.
the first. Adya, you'll go for the third one.
Yes, ma'am. I think
Yes.
he's pulling.
Okay, he's pulling. He's pulling the nail with probably a thread. Okay, and what is he doing?
Change in state of motion.
Correct. Change in state of motion. Here he is not changing any size. He's changing not neither the shape. He's just from rest. He's setting the nail into motion. Okay. Next. Next, Gia, come on. The fourth one.
Um, is he bending the scale?
Yeah, bending the scale.
Okay, so there's a change in the shape state. There's the change in shape,
Yes,
and,
change in
and in
shape.
and in the state of motion. Wait, no, not in the state of motion. In shape.
But what will it be? Push or pull?
Oh, it's a pull.
It's a pull.
It's a pull.
Okay. It can be push. It can be a pull. I think this one is a very confusing one. It can be both of them. Depends, no? You're pulling it towards yourself. You could be pushing it away from yourself also. So this, if you want, you can write it push. If you want, you can write it pull. But the important thing is that it is changing the shape and the size of the object. Okay, clear?
Yes.
Yes, ma'am.
Okay.
Clear.
Okay. So we'll go to our
Yeah.
conclusion. We'll just read the conclusion. It's very interesting. Next. Okay. So force, what we did up till now, it could be either a push, pull, squeeze, or stretch. Force is basically the capacity to do work. We started this, the first sentence, the energy to do work. Okay. Force will be mass multiplied by acceleration. Mass into acceleration. And force is such an thing or such an agent which will change the state of rest or state of motion of a body. Okay, if something is at rest, it will remain at rest until it is not applied by an unbalanced force. Okay, if there is a balanced force, it is not going to affect it. And what are the effects of the force? It could change the shape, it could change the state of motion also. Okay, clear? This effects is clear.
Yes.
Yes, ma'am.
Okay, we'll go to our next experiment. Okay, so in this experiment, I will tell you all what you all have to do. You all can that time you all can put your mics and videos on, and we'll do it together. Okay.
Ma'am, I
So
don't
what?
have a rubber ball. I have a plastic ball.
Yeah, you can use any ball. Okay.
Okay.
This rubber ball is normally put into this because when we supply the kit, in that we put a rubber ball. That is why it is written as rubber ball. Okay. So you can take a rubber ball on a normal surface, on any table or any flat surface, okay, and then you're going to gently give it a push. Okay. When you give it a push, what will happen? The ball will start to move. Now you're going to use your palm and you're going to put it in front of the ball. What will happen when you put your palm?
It will stop moving.
It will stop. So you using your first energy, your first muscular energy, you put it, you using that force, you put it into motion. Now by using again your only energy, you're bringing it back to rest. This was the first thing. You're going to change the state of motion of the object. That is, you're going to bring it into, you're going to set it into motion. You're going to bring it up to rest. Okay. Now what you're going to do again, similarly, you're going to again set the ball into motion. Okay. And just put the scale in the direction of the ball. And then you're going to tell me what happens once the ball hits the scale. The ball at the second time should be a little bit with more force. Is this clear? Are both the activities clear?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So now you can put your videos on. You can put your audios on also. Okay. And we'll see what you all are doing. Okay. Okay. So the first thing is right now your ball is at rest. It's in the state of rest. Okay. Now with your force of the hand, you're going to set it into motion. And with the other hand, you brought it back to rest. Correct? So now tell me, what did you all do in this activity?
We made a ball move and we put it to rest also.
Yeah. So using force, you change the state of motion of the ball. First, you brought it into motion, means you from rest, you brought it back to motion, and from motion, you brought it back to rest. Correct?
Yes.
Okay, good. Now we'll go to the second activity.
Yeah.
Okay. Now this time you can put it at a little bit angular. You can apply the force at a little bit angular. Is there any game based on such kind of motion and such kind of principle?
The
Oh, yes,
ping-pong game, the ball.
there was a game where there's like this.
What?
Yeah, there's a game called Swingers, and you have to press the space key, and in order for the little character to move. So
Okay. I think all the games are based on this kind of motion. You can name hockey, soccer, all of them are based on this, right? Right. The ball is already in motion. Okay. The ball is already in motion. Okay, by one player. What happens the minute the ball goes a little bit away from that player, the other players, will take it and will change the direction. So what did you do by using your scale? You were able to change the direction, right?
Yeah.
Yes. Then even soccer also which they play, football,
Oh, sorry,
right?
ma'am, my internet crashed.
Yes. So what I was saying that all the games, your hockey, your soccer, your uh, uh, football, all the games are based on this type of force and change in motion, right? Because the ball is already in motion. Correct? What do you just do? You are changing the direction by using something. So by using something, when you change the direction, by using something, you change the direction. You either speed it up, you speed it down by using something, right? So all the games are based on this kind of force application, right? Yes,
yeah,
Yes, ma'am.
yes, okay. Okay, so what did you all do in the second activity?
We changed the direction of the ball.
change the
We
direction.
changed the direction of the ball.
Yes, you change the direction, you change the speed of the ball, correct?
Yes.
So by applying force, you either change the state of motion. That is, when something is at rest, you bring it into motion, or when something is in motion, you bring it into rest. Or the second thing is you can change the direction of it by either increasing the speed, decreasing the speed. Also, you can do these things. So all the effects of force are brought about, and it will change whatever thing of the object is. Okay, means motion to rest, rest to motion, direction, and so on. Correct? Yes? Okay, we'll go back to our presentation.
Okay.
Okay. So, this ball was there. You either accelerated it or you retarded it. You could have also changed you could have also changed the direction of the ball also. Okay, so it is the change in the force. It is the change in the force that is going to bring about all these changes in your object. Correct?
Yes, ma'am.
Okay, next. So, this is what you observed. First, initially the ball was at rest. The speed of the ball at that time was 0. When you applied the force, the ball started moving, and so the force made the ball change its speed. From 0 speed, it came into 1 speed, 2 speed, whatever, XYZ. Example. Okay. So by force, you change the speed of the ball, you brought it into motion. Okay. By applying force, you change the direction of the object. The direction of the object was changed by using your ruler. Okay. And so using that, the force was uh, used to um change the direction of the motion. Now, if supposing the force was applied in the motion, for example, if the ball was moving and you moved it, you gave more force to it in the direction of the motion only. What would you do? Would you speed up or would you retard it? Did you get my question? If something is moving and in the direction of its motion you are applying it more force, so will it speed up more or will it retard?
It will
It will
speed up.
speed up.
It will speed up. If something is in motion and in the opposite direction you give it force,
It will stop. It will retard.
it will stop. It will stop. It will retard. Okay. So this is how it happens. So it is basically the force that is going to change the state of motion of the object. Okay. Uh, for today, these two were the experiments. I told you before only there's not much of an experiment to be done today, but the concept was very important to clear out, because if you don't understand rest, motion, it just happens, you just read it through. But if you don't have a thorough understanding of it, further times when you are doing your definitions and so on, it becomes very difficult for you all to understand what they are speaking about. Okay, so the force, what did we discuss up to now? Can all of you all tell one by one? Anyone can start.
Force is what causes physical change, and it changes objects from rest to motion or from motion to rest.
Correct. Good. Okay.
That rest and motion are relative
Yes.
forces,
Relative terms.
relative
The
terms.
unit of force is Newton or N.
Very good.
Force is
Yes.
equal to mass into acceleration.
Very good. Understood. Okay. Good. Good to go for today. Any questions you all have got related to today's topic?
No, ma'am, I had really
No,
fun
it's all
today.
clear. Yeah, it was fun.
Was it fun? With
Yeah.
little activity also it was fun?
Yes.
Yes.
Okay, okay, fine. So there are questions uploaded for you all. You all can go and see the questions. Okay, please attempt the question. If you all want, you all can see the presentation once more. So it'll go into your memory very well.